Hello everyone, thank you for attending this session on modernizing campus networking. I am Partho Mishra. I run the product and engineering team at Cumulus Networks. As most of you probably know, Cumulus has been one of the pioneers in the area of disaggregated networking for the data center. What is less well known is that we've done a lot of work starting about 4 or 5 years ago in the area of applying some of the same principles from data center networking to campus networks. And what I'll try to do in this presentation is share some of our perspectives, some of our learning in this area. For those of you who are new to our world of open networking, it's worth pointing out the potentially huge impact that open networking can have on your business. The most obvious benefit of open networking is, of course, the idea of disaggregation. Disaggregation allows IT teams to avoid vendor lock-in and provides them leverage in their procurement process to buy best-of-breed solutions. Now, operationally, the biggest benefit for our customers is the large-scale deployment of automation techniques, sometimes referred to as infrastructure as code, for initial deployment and operations of the network. Over the lifetime of the network deployment, this provides several operational benefits. Number one, it's easier to scale out the network, for example, to add more pods in the data center, since this is now just a cut and paste exercise. It's also possible to make changes to the network, for example, a configuration change in an automated fashion, and this leads to much greater consistency. It avoids manual errors, for example, someone fat-fingering a configuration and blowing away the whole network. And then finally, with open networking, after a few years of adoption, we have seen a nonlinear flywheel effect as more and more people in the community start to contribute and share code. The Linux kernel is probably the best example of this. And what we're now seeing in our world is the same type of community participation with projects like ONI and FRR and so on. Now, while much of open networking innovation has been focused on the data center, there has been a rapid evolution of networking use cases in campus environments as well. Now, I use campus in the widest possible sense of next generation retail stores, warehouses, factory floors, small, medium businesses, in addition, of course, to the traditional large enterprise campus facility, for example, something like a Fortune 500 company's corporate headquarters. The most dramatic evolution has been in the use of various forms of IoT devices in the enterprise for monitoring and control of physical processes, devices, and infrastructure. Operational technology systems are used to perform a wide variety of tasks ranging from monitoring critical infrastructure to controlling robots, and so on and so forth. Sometimes for something as simple as turning on the lighting in an enterprise building as people come and go in the building, or as a function of the time of day. Now, OT technology is used in a variety of industries, including manufacturing, oil and gas, electrical generation, distribution, and so on. And the pervasive use of these IoT devices leads to a situation in which, because these IoT devices are inherently untrusted, the network has to be designed around a zero trust model. It is no longer okay to trust any device or application that is quote unquote behind the network firewall. And this then naturally leads to the idea of segmentation and virtualization on the campus network to segregate the IoT traffic from everything else that's on that network. Now, what we are seeing in campus environments is also an increasing deployment of applications that use a microservices architecture. As in the data center, this changes the way in which network operators think about workloads and traffic flows with a lot more east-west traffic. And then finally, for a lot of modern campus environments, the old idea of guest networks is evolving into a full-blown multi-tenant network model. One example of this is with healthcare, where medical equipment companies will deploy their products and services running as an overlay on top of a hospital's basic network infrastructure. Now, in response to these trends, campus operators are updating their network design. The most important criteria for a campus operator is to take the opportunity to simplify the campus architecture and to minimize complexity. Now, a lot of them are also aggressively driving the adoption of automation and orchestration to deal with the inherent complexity of managing a large number of distributed campuses or even a single campus which has disparate requirements because of different departments, for example, in a setting like a large university. Many of our customers have decided to minimize or even eliminate the use of legacy features on campus networks because they view these as impeding or slowing them down in their objective of automating and simplifying the overall network deployment and network operations. And in fact, what we find is that in many environments, if the same IT team is responsible for both the data center and the campus deployments, then there is a natural desire to leverage the exact same set of tools to deploy and manage networking technology end to end. Creating this type of uniform operating model across both data center and campus helps reduce operational complexity and, of course, costs. So this then naturally opens up the door to the same approach that has been used for data center networks and to leverage the benefits of open, disaggregated networking. Now, I should point out that for many campus IT teams, there's also a financial reason that's triggering them to make these kinds of changes. Today, there's a built-in financial cost in having to renew very expensive support renewals from legacy vendors. So even if a campus IT team did nothing and kept the campus architecture unchanged, they still incur a large cost. So therefore, a lot of them have decided to bite the bullet and go ahead and use the funding that's available to design and deploy a new type of campus architecture. Now, from an abstract network architecture standpoint, the key difference between the legacy and the modern campus architecture boils down to a few key changes. Traditional campus architectures are based on a three-tier design. There's an access layer, there's a distribution layer, and there's a core layer. And in a more modern design, what we have seen is that many network architects are gravitating towards a leaf spine model, similar to what has been pioneered in data centers by the web scalers. And the natural benefit of a leaf spine model is the ability to scale out the design, in which a campus operator can add more switches at the spine or the leaf layer over time to accommodate the needs of their network workload. Now, many campus networks have historically used layer 2 architecture because it's just so easy to set up. And of course, all of you are familiar with the companion challenges, which is with spanning tree and the always present risk of broadcast and multicast flooding in a flat L2 topology. So in the modern campus architecture, we believe that it's possible to use a pure L3 design and use some of the innovations from the data center world, for example, unnumbered BGP, to address the ease of configuration challenge that has caused historically a lot of campus designs to gravitate to L2. So the benefit of an L3 design, of course, is that you can now leverage things like ECMP. equal cost multipath, which in turn leads to inherently better resiliency and and much better utilization of the network fabric. Now, in practice, what we find is that our customers make some very pragmatic choices in deciding how to evolve their campus networks. They understand the trade-offs, they understand the benefits of different approaches, and usually they're very pragmatic in terms of picking a design that best meets their needs. And we've seen three very common models. The first one is to keep the existing network architecture, to make no changes, but to move to a new generation of hardware switches. Due to a new wave of semiconductor devices that have come into the market in the last 12 to 18 months, the new generation of network switches offers some immediate benefits, higher speeds and feeds, more ports running at higher speeds, more powerful hardware capabilities. The CPUs are more capable, you have larger memories, you have much more drive capacity. There's also, for a lot of these devices, native support for VXLAN. So even if it's not an immediate priority to enable VXLAN, knowing that that is supported allows operators to plan for a future evolution of their network to exploit some of those capabilities. And I should also point out, most modern hardware switches will support both layer 2 as well as layer 3, so both switching and routing. So there's a great deal of choice and flexibility in terms of how to go between one and the other depending upon the network environment. Now, and as a result, for some of our customers, they choose to enable routing because they understand how to automate much of the configuration, and they like the advantages that they get from features like ECMP. The next step up is to use EVPN in the distribution and core. Now, this gets the operator to become familiar with EVPN VXLAN, including how to deploy BGP, including how to automate, and all of the other benefits that I talked about earlier, but without having to touch the access layer where they have the greatest number of switches and where there is the greatest end user impact. So again, this is something that we've seen a bunch of our customers adopt and deploy in the course of the last several years. Our most forward-looking customers are transitioning completely to a pure cloth leaf spine type design, where the leaf spine architecture is used to interconnect the distribution and the access layers based on the EVPN principles, and EVPN VXLAN is also used to connect from the spine layer to the border leaves. So in this architecture, it's possible to potentially eliminate the entire traditional core layer and connect the border leaf switches directly to the campus firewall. So we see all these different models of how the network architecture is evolving. Sometimes it's evolutionary, and sometimes, as you see in this example, it jumps right ahead to kind of the end state and takes a very aggressive, very modern approach. There are a small set of features not found in data center switches that are required in campus switches. The most important one of this is 802.1x, which is used for authentication of endpoints. As we discussed earlier, there's a wide variety of endpoints on a campus network, and particularly IoT devices that are inherently untrusted, and therefore it's necessary to use 802.1x as a way of verifying the devices that are connecting in over the first hop of the network. A second crucial feature that's required for campus switches is the ability to support power over Ethernet. Many endpoints are powered in this fashion, and therefore this is a must-have feature for a campus switch. A third requirement for a campus deployment is for switches to support legacy devices, particularly voice over IP phones. With a lot of campuses, you kind of have this ubiquitous infrastructure and a set of mechanisms built around quality of service profiles, dynamic VLANs, and so on that have been used to support voice services. And it's important to support those. And then the last one that I wanted to highlight is the ability to support the multi-gig PHYs as a way of interconnecting the switches with next generation Wi-Fi access points, which can typically use backhaul speeds of greater than 1 gigabit per second, and therefore the switches need to support those speeds as well. But outside of these, kind of small set of features, I would say that the vast majority of campus operators are extremely keen to not use additional features, additional legacy features that slow them down in their quest for automation and being able to use modern techniques for deploying and operating their networks. With any campus network, a crucial requirement is the ability to do remote troubleshooting and management. With many enterprises, they might have tens, hundreds, maybe even thousands of remote campuses, and it's not practical to dispatch IT folks to be on site to go troubleshoot and understand what's going on when something breaks. Now, a lot of campus networks still use traditional network management tools, which are built around SNMP, with all of the attendant limitations, particularly because of polling, particularly because of the overhead associated with the SNMP protocol. And consequently, it's not very well suited for large data sets. It's not very well suited to be able to get views of what's happening on the network in real time. Much more modern techniques have been pioneered in the data center, initially by the web scalers, and they're now used on a much more pervasive basis, where the idea is that network switches and also various other forms of network appliances and endpoints are continuously streaming out telemetry data, and then the network operations system process that telemetry data, analyze it, and in real time provide insights into what's happening on the network. A very pragmatic example of how this can be used is to do automated validation of the health of the network fabric. So we have a very powerful use case for this that we have developed at Cumulus, where the idea is that by looking at the state of network protocols, for example, BGP or CLAG, or by looking at the state of network interfaces, or by even looking at physical configurations of the MTU values set on either end of a link, we can in real time detect things that are not configured correctly or situations in which protocols are not behaving correctly, and run a very large number of validation checks. And this leads to the discovery of sometimes problems which seem extremely obvious but which go unnoticed. And it also allows us to, in many cases, detect some horrendously complicated network protocol problems which might not otherwise surface up using traditional tools. Well, what we've done in campus deployments using Cumulus Linux is leveraged a lot of the capabilities that I've talked about so far to create an infrastructure as code solution for our customers using a full CI pipeline. And the way in which this works is as follows. Configurations, topologies are created using our automation framework, Ansible, Jinja templates, and so forth. These are then validated in a simulated network environment using a virtual form of Cumulus Linux, which we call Cumulus VX. Now, based upon the simulation, if the simulation is results look correct using all the validation checkers that I described earlier with NetQ, then those changes, whether they are configuration changes, whether they are network design changes, those changes are pushed into production, onto the production network. And then using NetQ, we can verify not just that the changes were correct, but we can also compare the behavior in the actual network, in the operational network, with the behavior in the simulated network as a way of verifying that the intent of the operator was fulfilled. So, in summary, while much of open networking innovation has been focused in the data center, there has been a rapid evolution of networking use cases in campus environments as well. And this has opened up the door to the same approach that we have used for data center networks. And this has allowed us to leverage the benefits of open, disaggregated networking.
Hi, Ryan. I see a question from you. Let me just kind of quickly read out the question for the benefit of everyone. You had mentioned EVP and VXLAN at the access layer. Are there any current Cumulus-supported PoE switches that support this, or are any on the horizon? So you're indeed correct. There are Cumulus-supported PoE switches. There's a family of Dell switches on which we do support EVP and VXLAN. And these are scheduled for introduction through the middle of this year, so Q2, Q3, and so on. And happy to follow up offline with you on the specific model numbers. Would love to kind of get your feedback on kind of your use cases and how you'd like to use them.